All right. So last lecture's recording didn't have audio, so just to go over the assignment real quick. We got a question last lecture about whether like changing passwords and things like that are in scope for this assignment. Generally, if you have questions like that, the answer will be yes, but please do ask, and it is good that that student asked us so that we can make a clarifying question to everyone. There are very few things that are entirely off scope. Basically, pretend that you are an administrator on this system and that you can change whatever you need to. You're writing this report to give back to the home lab operator so that they know what changes you made. And so you can change passwords and things like that if you decide to do so. It's up to you. I mean, it's one of those things that you would write down in the report. The goal with the report is to be as thorough as possible so that you're explaining not only to just us as graders, but like in the setup of the assignment, the scenario of the assignment, that you're explaining to this person what you have changed. So pretending that you're kind of helping out some other server owner or something like that. That's the entire idea of the assignment. So taking notes of any vulnerabilities you find and patching them. Sounds good? Any questions about the assignment so far? Okay. Yeah?
So you said we can change passwords, but what is the thing that we're not allowed to do again? I'm sorry?
No, well, there isn't necessarily anything that you're not allowed to do unless someone asks a question and then it comes to mind that like, oh yeah, don't do that. The thing that you're not allowed to do, technically, is lock yourself out of the system. So just try your best to not do that. If it does happen, then we can revert your box, but that's not something we want to do for anyone because it'll reset all of your.
Resets all your progress, and I believe it is written in the assignment that there will be a point penalty if we have to reset the box.
I don't think we have that.
Really?
Yeah.
Let me just confirm. Sorry.
But it's up. So the thing with reverts is that if you send us a request to reverts, then it's kind of just up to us to do that. And so if you submit that request at like 10 p.m. on the last day, then there's a chance that we won't be able to see it in time, depending on how many questions you have to answer. So just be cautious. Defense is a very careful task. You have to make sure that you're not hurting availability. That was one of those topics that we touched on last lecture.
Is there a case where, like, if you patch something, you open another thing?
If you patch something, you open another thing? Not really. Like, this isn't really software debugging where you can add a feature and then that creates more issues. Usually, when you're taking down holes, it wouldn't hurt. It wouldn't make something more insecure, but it might make some features not work. Like, for example, if you're setting up a website and you say that I don't want anyone to be able to access this database, this one database, that might hurt the ability of some API that needs to access that database. So it wouldn't really introduce new vulnerabilities necessarily, but it could hurt how the service runs. I would say it's distinct from like software development where you could patch a bug and then it creates new bugs. But that's because you're adding more. When you're doing security, you tend to be decreasing the scope. Good question.
Yeah, clarification. I was mistaken. There's no point penalty for resetting, but as previously mentioned, it will clear your progress. So I guess note down what you're doing as you're doing it.
Yeah. We talked about IP tables last lecture. I'll see if I can get some resources out so that there's, people can attempt the extra credit even if they weren't able to make it last lecture. I'll see. I can't promise anything, but it just depends on how much time I have. But yeah, okay. Let's get into today's content. So a lot of times when we're talking about defense, we're often doing it with the context of incident response. You guys can all see my screen, right, on there? You can't?
The stage is gone.
The stage is gone?
I don't know if it's like,
One moment. Okay, issues fixed. All right. Incident response is kind of the context in which we do defense. Has anybody heard of this term before? Incident response? Raise your hand if you have. Or if you've even mildly heard of it, if it sounds familiar in any way. Okay, it's like a good portion of the class. Does anyone want to throw out a definition of what this might mean? Like what comes to mind when you hear the words incident response? Any guesses? I'll go with you.
When a hacker is causing an incident on your system, you go and respond immediately.
Okay.
For example,
Okay. 1K?
Like, I think this is saying like if someone has like breached your system or something or is doing something naughty, like you kick them out and like fix things.
Okay, kick people out, fix things. There's one more, Abdullah.
I'm not sure. They already covered most of it. But like,
That's fine.
I think it's like when unpermissible thing happens. Let's say an unauthorized access, or like you see a trace of something that should not happen, and you just kind of like respond to
Yeah.
that. By like,
Okay, so seeing things that shouldn't be happening happen, and then responding to that, and so trying to remediate. Right. So the common pattern I'm seeing here is that everybody's saying, so you have this system that you expect to be perfect, that you expect to be all secure, nobody can get in, nobody can do the things that they aren't supposed to be able to do. That's the ideal, right? That's what we want. The reality is a little bit different. And so, right, so if we're thinking about it from the perspective of Canvas, we are hosting our systems and we want to make sure that our systems are as secure as possible. So in the background, we're doing this defense, trying to find holes and patch them. And then sometimes things happen that are, I don't want to say out of our control, but you just don't expect them, because when you're the attacker, you have a lot more time on your hands than the defender does, is how it tends to go.
Police term for like incidents, basically.
It is a similar term to the police, yes. I mean, it just goes to like any type of investigation. Like whenever anything bad happens, trying to wait
You
remediate.
wait till it happens and then you backtrack after that.
So I would change the word waiting, but I mean, I get the idea. It's less of waiting until things happen, and we'll touch on that in a little bit. But yes, when things happen, you have to remediate. Is the idea. So the reality of the situation is that attacks happen. We want our systems to be as secure as possible. When you're working in a company, you want to make sure that your systems are basically impenetrable. But in the back of your mind that isn't the case, that there are probably actors who are already inside and they're just dormant. They're not doing anything until they find the time to strike, things like that. And so the idea of incident response is trying to find a way in order to remediate. So let's suppose you're a security team, you're Canvas, right? It's moment zero. You've just found out that like about 60 seconds ago there was a breach. Something just went wrong. Like you got a phone call from IT and they're saying we're getting a lot of reports about the website just being entirely defaced, entirely down. What is the course of action?
Undergo scheduled maintenance.
Undergo scheduled maintenance. Okay. Other thoughts?
I think send email for everybody that is in the service not to do anything or not to try to log in like the Canvas did. Send to everybody email.
Okay. Warn the
Don't
users.
interact with this. Yes.
Did you have your hand up? Okay. Do you want to say anything or no? Okay. Any others?
I think shut down the external access.
Shut down external
If you
access.
can, if it
Okay.
is in the service.
We're getting at good steps of like things to do. But what would be the absolute first thing you do? All you know is that there's an anomaly. You've heard that there's calls that things are going wrong.
You investigate I don't know what they call it, but like the routing thing. Like,
Investigate routing. Okay.
I think like you go to like Cam's website and see that it's actually defaced.
See that it's a face. Okay. So confirm the suspicions is the idea. Any other thoughts? Okay. Yeah.
The log file must be crazy.
Log files must be crazy. Okay, so the first step that we would talk about is basically what you guys said. Identify. So find out if the anomaly was truly an attack or a false alarm. One way to do that is by putting yourself into the shoes of the consumer and trying to see, are things going wrong, or is it actually as bad as it sounds? And they would find out that it is. We had another good idea of like looking through logs. The screenshot on the bottom right is what a security information event monitor management system might look like, showing logs all in time order. If you have a time where you started getting these calls, then you can kind of trace back and try to see what happened just before those calls happened. So look through logs, find out the who, what, when, where, why, how. So who was the attacker? What did they do? When did it happen? Which servers were affected? Why is a bit of a, ignore that one. How did it happen? Like how were they able to get in? We can assume why is for money, I assume, but And the other thing to talk about is how severe was this attack? How many customers will this impact? If you're in Canvas's shoes, then you're kind of like, you're like worried that you're just gonna get fired or something, because it's like everyone, as basically all of your consumers. And having that in mind kind of like shapes the rest of the response. Knowing how urgent this situation is shapes the rest of the response. Okay, so first step is to identify. Find out if this was even an attack and find out how severe the attack was. Let's suppose that you found out that it is an attack. You're in Canvas's shoes, right? You found out that there was definitely an attack from shiny hunters, regardless of who this may be. What would you do then? What's the next step? Consider that you are the IT for this company. You're the IT for instructor. You can throw out ideas. We can
Warn users the first thing? Or
warn users? Okay.
because the next one would be shutting down the access.
We can say warning users would be part of the identify. So once you found out it's an attack. Okay, actually that's a good one. We can talk about that. That's on the more, I guess, like policy side of things, but that is a good step. Yeah.
The ransom message has a suspicious link. Why don't we just download the text file?
Download the text file. Let's go to the hackers' websites and see what's on there. I didn't mean to make fun of that suggestion. It is good to confirm things. I would consider that more as the identify step as well, of like figuring out the severity. But you wouldn't necessarily, I guess if you were in Canvas's shoes, you wouldn't necessarily need to go to that website. You would probably have a good idea of the scope when you're in the identify step itself. You'll see that you're probably getting calls from all of these universities about how bad things are. But that is like looking into what's happened is not a bad idea. I agree. You had thoughts?
Just like try to isolate the system so you can look at what it's different.
Yes, okay, I do like that. Isolate the systems, see what's going on. Any others? Any other thoughts?
I don't know if you could use like the network management thing,
Mhm.
the one that you was using to see if there is any network traffic that is different from your device. Or
Do you remember which tool you were talking about?
I don't know, you used something to check when we were doing the website thing, or like it just checks if there's any internet requests.
Was this Burp Suite? Or the inspect element kind of thing?
Network.
Oh, okay. That would be more on the client side of things. So it's looking more into the like how a consumer would see it, which is again like this could be good from a consumer's perspective. From the security perspective, it might be out of the scope for things to look at.
Oh, okay, then basically the logs.
Yeah. Okay. Logs. Okay. I'm going to go back a bit. So we got a good a suggestion that was about isolating systems and then going from that route, like figure out the vulnerabilities that are on the systems. I forgot why I put the screenshot here. Oh yes, so this is a hint. This is a hint about what they might do. This has been the idea was mentioned before. Does anyone know where I'm trying to get at with this image?
Shut everything down.
Shut everything down, yeah. So that's the kind of like the brutal option, the last resort. Shut everything down. Isolating things is the more, like the, I guess it's the tamer option. That's what we want to do. Ideally, we just want to isolate a few systems. But the goal of this step is to contain. So limit damage, prevent further damage to the system. So what Canvas did was they just outright took everything down. But if there's a smaller scale attack and all you know is that maybe like a single database has been breached and all that's in this is like, what's something that's not like super important or life-threatening? Email addresses maybe. Like I can see that could be a possible escalation for attack, but it's just one specific database. If it just has email addresses, then you're not entirely screwed. I would assume, as opposed to what happened to like, if all of your course grades were out and passwords are out and things like that, password hashes, whatever it might be. So isolating a network segmentation. This was a topic we talked about last Thursday, where a defense team can put machines into different types of VLANs, like virtual LANs, or separate them otherwise by a router. So if you put a router in the middle of all of these devices, then it makes it so that the router will filter traffic going from device to device. So if you isolate the infected computers, then you can make sure that those infected computers can't talk with the other machines. So you might remember from last Thursday's lecture, we had the example of there was a server that was infected and there's a printer on that same network. And so if they aren't isolated, then the hacker who got into that one server can print out, you know, like a million pages of all black paper, and so they like waste $200 of toner. But if you have a network segmentation in place, then you can make sure that that infected machine will no longer be able to communicate with any other devices on the network. Potentially taking servers down is like, you know, the more nuclear approach. Yeah, I guess I spoiled it a little bit. So once you've taken things down, what's the next step? You've taken these servers down that are malicious. They have things on them. Where do you go from there?
Investigate.
Investigate. Okay.
What's leading to what you have, and what might have been the reason.
Okay, that's a good thought. Any other ideas?
Like look for artifacts that maybe they like haven't cleaned up properly, so you can find out like what the attack was.
Find out what the attack was. Okay.
I think maybe you could like set up like a clean server and then like add some kind of like additional like logging or some kind of trap to like figure out how they're getting.
Honeypots, would that be? So you're creating up a new server so that you can maybe they'll replicate the attack, and then you'll get more information from that. So if you have logging on another server, then you can figure out more information. Okay, that's a good thought. Not exactly where I'm headed, but that could be a good step to take if you're trying to find out more about how the attack worked. We're going to go under the assumption that the logging system was already good enough where they have a lot of information about how the system works. Keep that thought in mind though, because we'll get back to it later. Yeah.
Set up a bunch of landmines on the infected system, such that whenever a bad actor retrieves some files, their computer will be infected by a reverse virus.
We're going to say that the best defense is offense, and so we're going to infect them back. Okay, so good thoughts. I guess kind of like there is a theme here that among what I'm hearing, which is you have to have a response of some sort. So you found out what these attacks are, you found out what they've done, and maybe if you haven't yet, then you can set up honeypots or other types of servers in order to figure out more information about the attack. But we're going to go under the assumption that you're at this stage and you figured out everything about how the attack happened. So the next step would then be to remove the malicious content. So if they have a backdoor in the system, then get them out of the system. You should also have backups. So if you're a system admin who's been working on a system for a long time, then you'll be taking periodic backups so that if something goes down, then you at least have something to restore from. The ideal way of doing this is you back up the entire system image. This is something that you can do on your own laptops as well. So if you have a hard drive that's empty, then you can take a disk image snapshot, which means that you're copying all of the files from your disk onto this other disk, this like external hard drive. That external hard drive is just sitting in a drawer somewhere. It's not connected to the internet, so you can trust that it's safe. And so if something happens, if you like accidentally RMRF your root directory on your laptop, which I guess it happens, I don't know, you can restore from that backup. So you can grab that hard drive and reflash your system. So that was the case where you're the attacker, the accidental attacker on your own system. But let's suppose there's an actual red team who takes stuff down. Then you can flash your system with that, with your clean disk image.
Would running diff on these two different drives help?
Sorry, say that again?
Would running diff on these two different, the backup and the one you have, help?
Okay. So running diff, and the goal would be to
see what changed between the safe copy of the drive and the infected one.
Okay, so the idea is to diff the two drives. So you have the backup drive and you have your current drive, the current state with the infection. And you can diff them in order to find out what went wrong. So maybe how the attackers got in. That could work. It would take a while to run that command.
Yes.
And since these are disk images, it would be difficult to parse because they're all formatted in some disk format. So it's hard to tell what went wrong, but you could maybe like look through the differences in the file structures and see what new files were added in. That can give you an idea of the backdoors. And then through this step, you can like remove those backdoors.
Mm-hmm.
Does that make sense? Like the idea there? I think that's a good idea. Yeah.
What if the attacker put something malicious in like user-generated content a year ago, and then when you have to restore a year from back then, which undoes a year of work? What would you do then?
Repeat that first part. So the backups from a year ago, you don't have consistent backups, or?
Now, what if the attacker got in a year ago?
Oh, they got in a year ago. Okay.
But they're only causing incident now that they cracked their patches.
Ah, I see. Okay. Okay, good question. So the idea is that the attackers got in a while ago, and maybe you have a bunch of backups, but you only keep backups for about a year or about 6 months or something. And so even if you,
This, 'cause I need to open the,
no worries, I think I should be good on charge.
You still have.
Do you want me to move that? Let me move this carrier for you.
I mean, that's crazy.
So the idea is that you have backups that only go up till about 6 months ago or something less than a year, and so maybe they got in like longer than that. Because normally with backups, you don't keep them forever unless you have that much storage. So maybe if you back up to the oldest state, then it's still a state that has that is infected. So there's a couple ideas here. Generally, logs are like when you're setting up logging systems, you can set up a retention policy, which means you can set up how far back these logs go. Any company will have like basically petabytes of logs, and they put in a lot of money into making sure that they can keep those logs for as long as possible. I don't know if Jason, Ethan, if you guys have like numbers on hand for like how long logs are generally kept, but it's like they're like basically never deleted, I would say.
Senior
No,
design
so,
project.
in the medical field, the mandatory number of days is 90 days. So you must keep logs for at least 90 days. Usually organizations keep them for around 1 year to 2 years.
I think I googled that. They were like for Google or like big things, they keep them for like over 7 years or something.
Oh yeah, so there are also other things, like imagine if you have like sensitive medical records, for example, those kinds of logs, they might be kept up to 10 years, as an example.
Okay, so certain types of information will be kept for about 10 years. Are these system logs or like data logs? Or
They're the most sensitive logs, so things
Yeah, okay.
like authentication, for example.
Okay, so like authentication logs could be kept up for like maybe for up to 10 years. It all depends on the severity of the system, right? Other things might be only kept for, I guess, about 90 days, maybe a year, something a bit shorter. The idea is that you'll have logs that might give some idea for how the attackers got in. So authentication in particular is very sensitive, and we want to make sure we have information about authentication for as long as possible. So if they got in a year ago, we know the IP address that they logged in through just, from the attack that happened maybe 10 minutes ago or maybe a couple days ago. You can use that IP address and maybe trace back to see what, if there were maybe previous attacks that were launched by that same IP address or an IP address in a similar geographic location, which will give a good idea of maybe they launched an attack back then, and you can figure out what they did back then. So it's all reliant on how good the logging systems are. And again, keep that in mind because we'll go back to that later. Did that answer the question of like, what you would do if I guess it's a semi-answer of figuring out what went wrong, maybe like in the past. The other possible method is that if you have information that they got in a year ago, or I guess what I just said was under the assumption that you are able to look through logs and find out that they got in a year ago. But let's suppose you don't have those logs. The thing there is also part of incident response, where you're removing malicious content, but the entire goal is to harden this system. So even if you don't know how long they've been in the system, you'll at least know that you can't trust the backups. So you roll back from backups, but you know that there's a vulnerability in those backups because that's how they got in. So if you're reverting to last night's backups and they got in this morning, you know that this image state from last night was vulnerable because they found a way to get in just this morning, right?
Update if you did not update.
Potentially updates could work, right? So hardening the system can mean many things. Applying security patches, right? So updates. Removing backdoors. So you would do that full investigation to figure out if there's any backdoors. So per your question, if they even got in a year ago, you don't have backups from back then, you would still want to do a full clean sweep to make sure that there's no way to get back in. And this can be a very lengthy process, but it's just the way that IR goes. Did that answer the question?
Yeah,
More or
they
less.
won't have some crazy 0 days, right?
They won't have crazy 0 days. If they got in a year ago, then we can assume that the security patches will take care of it, and that's been discovered by now. I don't know if that's a great assumption to make, but it's a possible assumption. I guess a lot of what I'm saying is reliant on wishful thinking, but it can be true that those problems have been remediated in the past year, essentially. Anti-malware can also help. That one's a bit less.
So you work based on what you have, and if you don't know about it, you just assume it's been patched.
So you work based on what you have, and if you don't know about it, then you have to do. You don't necessarily assume that it's been patched, but you might have to do again that clean sweep. So you have to go through and audit everything. That doesn't necessarily mean auditing all of your code, but if you're a company, most likely you're running proprietary code, which means that it's very hard for an attacker to perform a 0-day because that code hasn't been released to the public. Like they can't just like go out and
It's a private code, yeah.
it's private code, right? So they would actually have to tinker with the code on your systems because the code is only running on your systems. So you'll get a bunch of logs of them trying to infiltrate, right? And because you have all those logs, most likely systems have defense measures in place. And again, we'll talk about this in a little bit. You want to try again? Yeah.
Yeah, let's check this now.
Sure.
The regular laptop input worked for me again, so I just want to see if
It detected.
see if it'll work now for you.
Let me see. Okay, this is not working. Let me stop the stream real quick. And then not start streaming. Okay, I think we're back. Let me double check. Yeah, cool. Okay. I have lost my train of thought in the past 4 minutes while we were doing that debugging. But okay, eradicate. So anti-malware. Do you guys remember where the discussion was? We were talking a little bit about different methods for how you can do that, and also concerns about, you know, if you don't have logs going back far enough, is that enough? So the entire point of the eradicate stage in incident response is to do hardening. And you don't know what the vulnerability is necessarily that they got in through. You have logs that can give you information about how they might have gotten in, what services they might have exploited, but you have to be suspicious about everything on your system. So the logs can tell you where to look. It might point you towards the vulnerability, but you need to look not just at that vulnerability itself, but opening broadly to even just doubting other services on the system, regardless of whether you know they're infected. And then doing the hardening. Any questions about that? Or any other comments? Yeah.
When in doubt, should we just add 2FA to everything?
When in doubt, should we add 2FA to everything? 2FA can help with, this is more of a client-side thing, so if you're a user, then 2FA will help make sure that users' accounts don't get hacked, which can be a good thing as well for enterprise security. Like, let's suppose you're worried that a hacker got in by cracking the password for an employee's account. Then yes, 2FA will help because it'll make sure that it'll add another layer of protection for those passwords. So it's not only that they have to get the password right, so it's not just password cracking, but it's also doing an additional check through the second means, like whatever that second factor might be. But it depends on the way they got in, because if they got in exploiting a software vulnerability, it might have bypassed authentication entirely, and so in that case 2FA wouldn't even be in scope. So it depends, but it can help towards things like this. Yeah.
In the case of like where the issue is, let's say like a git commit or something like that, like a previous git commit or something that you did not.
So we're talking about homework 4.
It's yes and no. The thing is like, how do you clean up that completely? Where even if it's there, do you just take out login permissions of that leak thing, or
yeah? So
how do you take the whole thing out? Do you just merge the commits, and what do you do?
Let's broaden it then. So let's suppose that some type of information is leaked, like credentials are leaked. So where do you go from there? If you're thinking about it from that perspective, the eradicate step would mean trying to delist that page first of all. But the first step would be actually not just delisting that page, but actually removing that login entirely. So we'll talk more about homework 4 next Tuesday. But there was a way to get in, which was an SSH private key, which was inside the Git repo.
Which pretty much everyone found.
Pretty much everyone found, right? So good work to everyone.
In the name, though.
Finding the name, yeah. Again, we'll talk about that Tuesday. But yeah, so if that happens, then you want to revoke that private key. So go into your system, find out what user had that private key, and take that out. Lock down the account. You could temporarily disable the account. Remember, this would be more of the contain step. Like taking servers down. It would be taking a single user down, which isn't necessarily terrible unless it's like the CEO's account or something like that. Some technology official's account.
What I meant is like it gives a clue for a structure. Let's say if the password wasn't that lengthy, like the range of the password, let's say 6 or 7 character for the like 100 whatever that was.
Yeah.
And if you give that pattern to somebody, they could just brute force it.
They could
so
brute force it.
You just want to try to kind of like take that out. If you
This
merge the commits, would that take it out? Or
merging it would not. So This would be the. So how would you take it out of the system? Like how would you take that password out of the system?
Yeah, like if you remember the commit where when you added it,
Yeah.
the commit where you deleted it, the whole span.
Oh, I see.
would
I see.
that take out that
No.
vulnerability, or
So
would that just condense it?
it would. This is a tricky question to answer because I'm not too sure about the inner workings of Git. But any commit that you make is never hidden. So you can do this thing in Git where you force push a commit, which means you let's suppose.
Sorry, it's
You have
manual.
no, that's fine. You have the initial commit, and then you have a commit we'll call E, which is like it contains like a private E inside here. Locally, you can roll back to init, and then push a new commit here, which is called F, which is like the actual data that you wanted to push. So it's just E minus that private key. You have this commit called F now. And you can see E is kind of detached. It doesn't have anything following it. And we're also just going to remove this link entirely so that Git commits are generally sequential, which means that if you look at it in GitHub and like look through the commit logs, kind of like we did for assignment 3 for the OSINT challenge, then you would see init and you would see F and you wouldn't see E. E would essentially be unlisted. But that doesn't mean there isn't a way to get there because there is still this link from init to E, and E contains that private key. So even if you're on GitHub and you force push a commit to force F to replace E, E still exists. It's floating. It doesn't have anything coming after it. And technically,
On the local machine doesn't exist.
on the local machine it doesn't exist? Okay.
GitHub just saves everything as a record. That's why you see it on the activity log. But when you do that on your own machine, like for example, you do a amendment of the commit,
Right.
that doesn't exist anymore. in your
So
local
this is why it's a force push, I believe, because if you just do a normal push, GitHub is the thing that's rejecting it, to my knowledge.
No, so if you rewrite your own history on your local machine, your own history
Yeah,
is written.
we're talking about pushing though.
Yeah, so that's only because GitHub
Yeah.
logs it.
Okay, so it's because
So
GitHub logs
It's
it.
dependent on the version, the destination machine that gets pushed to. So if
Okay.
you see something else like GitLab or Git or whatever, that implementation could vary.
Oh, okay. So it could still be showing for.
It could show all the stuff that you've ever done, like what GitHub does, or it could do something else. But we already know GitHub is inherently very vulnerable. Like if you have hidden repos that you fork from, and you then decide to make them private later, those commits are still available for some reason. Like it's a mess on GitHub.
Oh, okay. Thank you.
So in that case, okay, good insight. So in that case, it can be true that, so depending on the Git infrastructure you're using, like if you're thinking about homework 4 where we use Gitty, it might operate differently. I don't know, but it might operate differently where maybe E will be entirely unavailable. GitHub will keep it. So that means that that private key is still accessible. So the only way to get rid of it is not on Git.
Discarded.
It's discarded, right, on the system.
Even locally, it still like keeps it around for a bit. Like it does like GC, like garbage collection. So like I think it's like 30 days by default, and then it'll delete.
So there's a Git commit retention policy.
Yeah, like that's why you can use Git weblock to recover.
Oh, I
commits.
see. Okay, interesting. So even local Git can't be trusted immediately. Yeah.
Without someone sending you a well-organized report, how do you know that you have something wrong with your Git system?
Without somebody sending you a well-organized report of the Git system, how would you know that?
That someone sending you a report of, here's everything your system is vulnerable of.
Oh, okay. So without getting reports of what vulnerabilities exist, how else would you be aware of it? Is that the question?
Yeah.
There is no other way. Someone has to do the hunting. Whether that means you hire a pen testing team or you do it yourself. But yeah. If like for example, if you had a vulnerability with your Git framework, then you would have to hire. Actually, this is pretty common among a lot of like open source and also closed source, especially closed source projects, where they'll hire not bug testers. What are they called? Auditors. Bug bounties are a thing. Yes, that is true. Bug bounties will be like generally opening it up to the public, and then whoever finds something, they'll get like a cash reward for that.
Will they get to prison if they do?
Generally, they're given a scope. Apple had a bug bounty, I think, about a year ago for their Apple Intelligence stuff, right? Was it something like that?
Private cloud compute up to $1 million.
Private cloud compute up to $1 million. So I don't think they would go to prison depending on what they end up doing. Go Buster. I don't think we'll. No comments. I don't want to give legal advice that I can't uphold. Bug bounties are one thing. The other thing is audits. So, for example, I like to use this program called Obsidian to write my notes for a lot of different things. And Obsidian is a closed source app. So the question that a lot of people have, because this is an app that's very common among like open source users, is how can I trust this app? So they hire third-party auditors to make sure that their code is good, which is why we can kind of trust it a little bit. Yeah, the nervous chuckle was a good response. Okay, I'm going a little bit slow here, and I guess there were also some hiccups, but we'll continue. So let's suppose we've now eradicated the systems, we've now applied these patches. Where do we go from here? We can assume that these systems are secure by now. Logical next step, yeah?
Like, we want to bring the servers back up.
Put the servers back up, right. So we call this the recovery step, where we start to redeploy systems, put them back into production. And very importantly, we need to make sure that the flaws that enable the attack are now removed. Those same vulnerabilities are now out of the system. Otherwise, they're just going to get back in again, right? So this is a time where it's really good to do a lot of monitoring to make sure that that re-exploitation doesn't happen. Because we want to make sure that things are better. We want to make sure that we've improved from where we were at moment zero. The next step from there is to basically just document everything. And this is what we've been trying to get everyone to practice throughout all of our assignments, right? As annoying as the report might be, this is what goes on in the real world. This entire, it's a 5-step process. It's actually a 6-step process. I just removed the preparation step, is from SANS. So there's this agency that makes a lot of security certifications, and it's very similar to the one that's also given by the National Institute for Standards and Technology, which is the department of the US government that manages a lot of security policies. All of them have this as like the last step, lessons learned. Document everything that you found, document the entire incident, update your procedures to make sure that you have reflected on this attack and you know what to do next time. So we can rest assured that Canvas and Instructor has probably assigned their ITs to be doing this for like a month straight. That's an exaggeration, but you know, this is basically the next step from after an attack has been found. Okay. So incident response, we've talked about a lot of, I hope we've talked about it in enough depth where it makes a lot of sense of like what this entire process is, how you go from incident to having resolved it and put things back into place. So this is something that takes a lot of time to do, right? Clearly there's a lot of steps to it. In order for incident response to succeed, what do we have to do before any attack happens? How do we prepare for an attack / how do we prepare for incident response? Mm-hmm.
How do you respond if you have no logs?
How do you respond? Great. So we can't respond if we don't have logs. Other ideas?
Maybe make incidents to respond to.
Make incidents to respond to. No comment. You can make your own economy if you want to. That is true. Not the best idea, but it's possible. Other ideas? Yeah.
Like you probably want to assemble like a team dedicated to incident response.
Dedicated team that is trained in incident response, so make sure everybody is prepared, has policies going into, so that they know what to do when an attack happens. Kind of like, if you grew up in California, then I'm sure you're very used to having earthquake drills, right? Like once every couple months, duck cover and hold onto a table.
Fires too.
Fires too, right. It's a very similar concept. Like a drill is used for natural disasters. It's also going to be used for IT teams who are trying to make sure that their systems are safe.
Keep like 24/7 shifts or something like that.
This is a thing, yeah. On-call cybersecurity experts. So we have, yeah. So in the same way that a lot of doctors will be on call, where they have to have a phone next to them at all times, so even when they're sleeping, they can get called in on the job and have to go do surgery on someone. It's a similar thing in cybersecurity, where a lot of like big companies, they'll have to have on call and as a system. So they'll have a security team or multiple security teams, and they'll have someone on that team who is like for 1 week on call, which means that they can get a call from any client at any time, and they have to go resolve that client's concerns. And this can be, pretty great if you have if you're a company that has clients that are all around the world. You have to wake up you have to wake up because when you're sleeping, they're awake. Yeah.
We should also make a kill switch, like have a big button that'll make your entire system go under scheduled maintenance when pressed.
Yeah. Okay. I know this is like something I joke, but it can be true. You have to have the procedures in place to make sure that you can take things down. Okay, so logs, know what to, so having good procedures. Other ideas, potentially? What was another one of those concepts that we needed in order to make sure that we can put our systems back into place? We talked about logs.
Backups?
Backups, right. So taking good backups, making sure that you have a good copy of what's going on, so that you can revert to that, which will at least help while you're trying to fix the vulnerabilities. Because again, those backups contain a vulnerability, but at least you have something to work off of that is uninfected, even if it has the potential to be infected. Okay, good points. Any other comments or questions? Okay, yeah. So those were the main things we wanted to talk about. Let's get into defense, right? So the entire point of incident response is defense was imperfect. We want to know what went wrong and how to improve. Before incident response even happens, you might have this phase of being confident that your security infrastructure is as good as it gets, right? And this is because of the defense phase, that we've done a good job of setting up the infrastructure that makes sure that attacks are unlikely, even if they do happen. And even if they do happen, you have procedures in place and you have the systems in place that will allow you to do a good job of incident response. Without incident response, defense will basically stagnate. You can never improve your defensive posture. Let's suppose the software team at your company has set up a system and you're on the security team. You're on the security team at Canvas. The software team has set up this new system called Instructor, right? Right, no, other way around. You're the security team of Instructor. They've set up a new system called Canvas. You don't know what it does. Keeping IR in mind, what do you do? How do you make sure you're prepared for IR? How do you make sure that attacks are unlikely?
What is IR? Initial for?
Sorry? Oh, incident response.
Oh, okay.
Yeah. Good question. Thank you for asking.
You explore the attack surface,
Explore the attack surface. Do you want to elaborate or?
which is interact with everything on canvas.
Interact with everything. Okay. Yes. Others?
I assume when you work for the same company, you can also ask them for documentation.
Ask for documentation, so investigate the system. That's what I'm hearing from you both, right? Whether you say like that's the kind of idea of like investigate what's going on with the systems. Okay. Other ideas? When we're talking about the infrastructure, we talked about logs and backups. So with that in mind, what would you most likely want to do? So, and okay. Do you want to elaborate a bit or just the one word? That's fine. Logs, right. So you want to set up the logging infrastructure because by default, logs are being collected. We kind of talked about this with systemctl last lecture. Let me just pull up the terminal real quick.
That was like a wild guess.
Yeah, it's true though. So I'll talk about it later. How about that? Because it works just better with the flow of the lecture. But logging. So we need to set up logging infrastructure, which means that we need to have a server that's dedicated to collecting logs. We need to have a whole, again, it's like, it could be petabytes of data. We have to be ready for collecting petabytes of data in total. So setting up the actual compute that will collect logs.
Do we try to isolate pieces or like not make them all locally connected, like
Yeah.
introduced router
This
for
is-
extra security?
This would be true, yeah. So making sure that the logs don't go down, right? So like, what if they hack into a system? You need to make sure that the logs are protected. There's a couple ways to do this. One is through that network segmentation. That is the first line of defense. Second line of defense would be mirror your logs. So every maybe a week or so, have the little logs be put into like, it's kind of like the analogy I was making of like the hard drive that you can keep in your drawer that contains your system image. You can do the same thing for logs. So every so often you back up a unnetworked state of your logs, which means you take an image of the logs, put them somewhere that isn't connected to the network, and then keep them there. Things like that. That is a potential idea. I'm not sure if that's exactly what goes on, but it's an idea to make sure that the logs don't go away. Yeah. Other ideas? Backups? How about that? Right? So
Yeah.
taking backups of systems. Yeah. So the first thing that we want to do is, we were talking about investigate, right? So someone mentioned, find out everything that's on Canvas, figure out what's running on the system. We don't even know what's on there necessarily. We don't know what's open, how people can interact with the system. So we need to do that first. Think about it from the perspective of a penetration test, right? Does anyone remember what the first step of a penetration test is? Well, there's two possible answers, but yeah.
Recon?
Recon? And anyone else want to say anything else? Were you going to say something? Recon, right. So My knowledge is a little bit blurry, but recon would be like before that. So like figure out what's going, like gain information about the company, right, or like things like that.
Map on the company.
You could do an nmap, right? That's what I was trying to get at, and then I remembered that recon is actually the first step, and so there was technically something before that. But yeah, so once you're, if you're in the perspective of, you already have the information about your company, then you would kind of, when you're doing defense, you would kind of ignore that recon step, which was, you guys still got the right answer, but to the question I asked. But what I was getting at is that you would do the nmap. You're just trying to look from a purely technological perspective because you know everything about the company, right? You probably have access to all of the employees anyway. So nmap is what you would run if you are trying to investigate from outside of the system. You would try to send probes into a computer in order to figure out what's going on there. But if you're already on that computer, the computer has entire knowledge of what's going on, right? So you wouldn't nmap it, or you wouldn't run an nmap on itself. Instead, you would try to query from the system itself to see what ports are open. This is the command that you would use to do that, ss-plntu. I'll just run that in here. And we can get some information just directly from that. ss is a command that will show, let me just type man ss. It's another utility to investigate sockets. If you haven't taken 150, for context, sockets are the files that are used in order to track ports. So open ports, open connections. This is how programs will communicate with the internet. Will communicate on the network. So every program that is running on a system will have a socket, every networked program. Let me just repeat that entire sentence. Every networked program on a computer will have a socket which refers to the ports that it has open. So for example, you can see .54:53, 53 is the port. This is on UDP. It belongs to systemd resolve. Systemd resolve is the module of systemd that deals with DNS resolution locally. So this will be running on basically all Linux systems in order to, whenever a domain is accessed like google.com, systemd resolve will handle that request and escalate it upwards as much as it needs to, like maybe ask the internet who is google.com and things like that. This is a ss-plntu will give us information about all of that.
Can we also check the versions of software we have and the metasploits for that or whatever that is?
Sure. So check out the versions, find the CVEs, the vulnerabilities that could be on there. That would be good to do. So figuring out more information about what's on the system. Let's just look through this file here. Like what do we see here? What stands out? Ignore the systemd resolves. Yeah.
Do we even need to worry anything about loopback?
No, kind of, because if they get in, then they can exploit the loopback stuff. But if we're talking from the outside perspective, then probably not. The question there is based on the idea that if something is hosted on loopback, then only you can access it while you're on your own system. Loopback is something that only you have access to. Whereas if you see these 0000 IPs, that means that it's the service is being hosted on all of your interfaces. So any outside computers on your network can access you using those ports. Does that concept make sense? Any questions about that? I think we might have talked briefly about it in server operation. Yeah. So from this log, pay attention to the process call on the right hand side. What is running on the system? What are some words that stick out?
SSH and exim.
SSH and exim. Okay. Other idea?
I see FTP working.
Right. FTP is on there. Any others? Kind of corroborating that, right? So yeah, SSH. We'll focus on FTP and SSH. Exim, I'm not actually sure why that's there. That could be a component of FTP potentially, or maybe something else I installed while I was working on it. But yeah, SSH and FTP are what we want to primarily talk about for today. And so this command will give you that insight. You can also use systemctl directly. So systemctl, like again, I know that the video was entirely muted, but is the framework on Linux that is used in a lot of distros, probably most Linux systems, that will give you a good idea of what's running on the system. So systemd is the suite that is actually being used in order to start up services and track the status of services, and it has a lot of responsibilities, including that resolve function.
What would you actually do if there's like some random service that you don't know why it's there?
So yeah, I didn't know that why XM was here, right? So what would I do in that case? Investigate. So the entire point of this phase right now is to take note of everything that's going on. So if I didn't set up this box, then I would definitely take note of of the fact that there's something listening on port 25 and I don't know what it is. Yeah, so that's a good point. Like when you're thrown into any new environment, and that could be a homework environment or anything else, you want to figure out your surroundings, right? And so you would run this command, you would take note of everything. Systemd resolve will just know as part of the way Linux works, so we would kind of move past that. But we'll see that SSH is on here, FTP is on here, port 25 XM is there. Those are things that we would all take note of and like literally write down so that you don't forget about it. That's a good thing to do throughout this entire process. Anyway, systemctl can also be used in order to see in order to list the running processes. So there's a lot of stuff here. The command that I ran is specifically showing the active processes, which means that services that are currently running. Let's see. We can see there's cron here. We kind of expected that because that's part of how Linux works. XM is mail transfer agent. Again, I don't know why that's there, but I guess I'll look into it. FTP server is running. Other things that stick out. A lot of times when you're looking through this command, you'll kind of like get tuned in order to know what to look at and what not to look at. dbus might sound interesting. This is just the way that Linux works. It's like it's another key component of Linux that allows inter-process communication. So, for example, it's what's used in order to allow apps to store secret passwords safely, things like that. And then right below that, we see OpenSSH server socket, right? In my opinion, I would say that it's generally a lot nicer to use this command because it just shows you the open networked services, but systemctl will also show you things that aren't networked. Like for example, dbus is not opening any network connections, but it does exist on the system. And so if there's other services that are like that, where they just run in the background, then you can only get that information through systemctl, not through SS, because they don't have network connections. Mm-hmm.
So you mainly would do this one if you're trying to block outside attacks.
Mm-hmm.
And the other one is if you are trying to re-enhance or make sure the system is working
Yes.
externally and internally.
We could say that. So yeah, SS will allow you to look for vectors of attack. Systemctl can show you vectors of escalation. We saw cron in there, for example, right? Did anyone find that in homework 4 that there was a cron stuff going on? Yeah, a few people noticed. Yeah, so there was a cron, like some malicious cron job, I believe, or not malicious inherently, but you're able to exploit it. It gives you a good idea of what you can do in order to move up the stack. Yeah. Next, we talked about backups, right? So after we've investigated the system, we would go into backups. So store config files, databases, other stuff, so that if hackers delete data, like suppose if Shiny Hunters got in and they just deleted everyone's grades, like you need to have something that you can back up from. And I know we've talked about this like to death already. So there's two main things to focus on. One is configs, which is they outline how the service runs, and the other is data, which outline what the service stores. So, for example, if you have a website, configs would detail like where are the website's files located, like where exactly are these HTML files that we're trying to serve located on the system. It's just like the directories. Like all you're telling it is the directories of where these are located. Maybe what port do you run the website on? Things like that. It's all features of how this website is being run. When we're talking about data, we're talking about the actual HTML that's being used in order to run that website. Like so, maybe the HTML, the CSS, the front-end JavaScript. Also things like credentials, so databases that are storing users, things like that. That would all count as data that are generally written to during runtime. So like while a website is running, that's when these authentication databases are being written to, right? This isn't something that the web server has to worry about directly. It's something that happens while the service is running. You can argue that HTML is maybe an exception to that, but generally if something is being written to during runtime, then it counts more as data rather than configs. Does the distinction there make sense? Any questions? Okay. The reason I bring this up is because a lot of times when we're backing up services, it entails a lot of Googling. So you'll go ahead and go into Google and figure out what's going on. So in order to figure out what to back up, you might look up how to back up VS FTPD configs, how to back up VS FTPD data. So just looking that information up so that you have something that to go off of. Mhm.
Should we set up backup on the upcoming homework? Because we kind of need another drive for that, right?
So for the homework, I don't want to say like this is an extra credit thing because I don't know if we'll necessarily grade that. I think it's something to keep in mind, and maybe if you want to try it out, feel free to. We haven't. It's up to you. If you have time to, then that would be good to do. But it's not something that you're required to do.
Not necessarily you have to back up to a separate hard drive, but just like somewhere else on the computer. Like say if I were, well, here's an example from CCDC competitions. We don't exactly have a separate computer we can just plug into the competition network because they don't want us introducing, outside electronics. So all we do is we make a copy of, say like an FTP share, move it to a different folder in the computer, and when the red team inevitably blows up the FTP share, we can just like recopy the folders over. So copies don't have to necessarily be to a different computer or different hard drive. It can just be a different spot on your same computer, just somewhere that you can machine with them.
The ideal, if you're in a corporate environment, is that you will have a dedicated, again, like unnetworked hard drive that is storing backups that you can just put into cold storage so that you know that it's always safe. But the practical, what happens during competitions that we compete in is that we don't have that, so we would just put it somewhere else in the system. And so during the homework assignments, you can do that.
Do you make it as a partition?
It's up to you. Generally, you don't want to repartition Linux during runtime. Like you don't want to repartition your drive while it's running. And I also don't think that you should do that in a virtual machine now that I think about it. So don't do that. But that is a potential solution, yes, in the real world.
Is there a good way to like make sure that they don't just like blow up both like the original folder and the backup folder if they find those?
So if they do happen to get into it, you can make it immutable, I guess, but even that has its flaws. Like chatter is the command, right? CHATTR, change attribute. You can use that in order to make it so that those files cannot be written to. But then if the attacker has sudo access, then they can write to it, so they can delete it. It's tricky. Like when we compete in competitions, I will admit they're not always 100% realistic because there's just sacrifices they have to make in order to make a simulatable environment that they can afford. So yeah.
With making a deceiving names or extensions.
Yeah.
Pretty helpful.
So this is we're getting to the realm of security by obscurity, which isn't which you ask anyone, it's not actually security, but it's getting somewhere. Like you're at least adding more steps. So it isn't a solution. Do not think it's a solution, but it's arguably better than nothing.
Okay.
Yeah. Does that make sense?
Yes, it does. Because the craziest thing, like for Linux things, you could still search if there is a word in a bunch of files.
Yeah.
With a PID.
You can encrypt it if you wanted to. You can encrypt it and like store it as like encrypt it with a password. Zip it with a password. You can do that on Windows as well with just random files, or any operating system really. You could do that with your backups as well, so that it's harder to look for. So we know that we've backed up these configs. Now we need to look through them. What problems exist in those config files? We'll talk more about configs in a moment if we have time. Otherwise, we'll save it for Tuesday. You want to write down all of the observations that you make. Basically, just document everything as you should be doing throughout this entire process. So when you run ss-plntu for that first time, document everything. Document what ports are running, what protocols they're running by. So which ones are UDP, which ones are TCP, because that gives you a good idea of the services that are running. And then while you're looking through the configs, go service by service and figure out what's wrong with each one. Yeah. Next, you want to go ahead. Yeah.
How do you figure out what's wrong with each one? Like, just look at the configs or try testing them?
You can try testing them if you were sure that your tests are non-volatile, but a lot of times it does entail just looking through the configs and going detail by detail to figure out what's wrong. And we'll show an example of that again either at the end of this lecture or next Tuesday.
Do you check the schedule, task schedule as well?
That would be, yeah, we'll talk about that in a moment. So now you've collected all this documentation and all the vulnerabilities, we move into the remediation step. So use the documentation, figure out which ones are actual vulnerabilities and not features, which which should be clear to you based on the system requirements and everything, and then patch those vulnerabilities. Remove the malicious configs, keep the things that are good. So now we're pretty sure that our system is secure. We've done the remediation. We next need to basically make ourselves even more prepared for incident response. So set up firewalls to prevent the possibilities of attacks, set up logging systems to make sure that you have a good way of keeping track of intrusions, potential intrusions, so that you can separate anomalies from actual attacks. Write up incident response procedures. This could be things like, what do you do when an attack happens, and then performing those drills, right? Again, we were talking about earthquake drills. Same thing happens here. Same thing applies here. You have to make sure that the entire team is prepared for everything that they need to do. Preparation is actually step one of the most incident response guides. It happens before the incidents even happens. You just have to make sure that the team is doing these trainings and is well aware of what they need to do once an attack happens. And so that kind of goes along here. So right after this fortify step, the ideal is that you're basically ready to go right into incident response if an attack happens tomorrow. Let's see how we're on time. Okay, got a couple minutes. Any questions? Okay. We can talk a little bit about Linux then. So generally for services, we're talking about config files, right? Those config files will exist in /etc. /etc is where system level config files will go to. So if you run a service just as a user, they'll go into your user directory. But if you're running a service as a system, which is what most likely will happen whenever you're running a networked service that needs to be accessible to people on the internet, it will exist in the /etc folder. So we found vsftpd was on that system. We can go ahead and edit this vsftpd.conf file to look more into it. So let's do that. This is the wrong window. So let me type vim etc/vsftpd.conf. Okay, we see this entire file. I've uploaded a trimmed version of it to the course GitHub. Maybe take a look at this whenever you get time. Actually, we can just look at it right now, and maybe in the next 30 seconds you guys can find out what's wrong with it. Okay, look through this. We can talk out loud just like right now. What stands out? What looks terrible right here?
Anonymous can upload files?
Anonymous can upload files, okay. What else might it be? You've hit the nail right on the head. So your question that you asked earlier was, how do you know when configs are bad? Sometimes it'll just be as obvious as that, and you can just tell that something is wrong. Other times you'll see that there's something that's you wouldn't expect. Like maybe you'll come across a config and you just don't know what it means. To me, I have no idea what this means. What is transfer log enable? Okay, I guess it does say log. That could be a good thing. It just looked like a bunch of gibberish when I first read it, so it seemed weird. But mostly it just means logging transfers. There could be other things in here that look weird, like SSL enable is set to no. Maybe that sounds like a bad thing. SSL is being used in order to make sure that connections are confidential. So the fact that that's disabled could be a red flag for us. But again, there could be examples of flags that you'll see that you just don't know what they mean.
What do they mean by listen no for the first one?
Yeah, I'm not actually sure about that one either. Listen no, do you know?
What? I think it's don't open an IPv4 port.
But I think it is.
So the listen IPv6. Listen is disabled, but listen on IPv6, yes. So maybe it accepts IPv6 connections and it doesn't accept IPv4 connections. But I'm working off of memory, setting up assignment 4. So I would also recommend if you see stuff, just Google it. Google it, ask insert LLM to explain it here. I guess time a good reminder that if you're struggling, it's fine to ask questions from us or to ask whatever internet resource you are. Just don't use AI to write your reports or put anything generated by AI in your reports. But you're allowed to ask it for help. How do I do X, Y, and Z? Please do that.
It's kind of just either way, when you Google anything, you get an AI generated search or response.
Yeah.
I mean that's not strictly against the rules. That's just the way that the internet works now.
Because it was asking me to put commands for the metaspoils.
Yeah.
I just didn't know how to make any sense. So.
Using LLMs as a substitute for Google is all right. We just don't want you to use it as reports content. We don't want you to ask it to write a script for you and things like that. Anyway, but like if you do have questions about like specific flags that are in a config, then there's always man pages that will go over those types of flags, and so you can investigate further. When you're writing your reports for homework 5, make sure to explain what's going wrong. So if you see a malicious config, then write that in the report so that so that you have something to go off of and explain why you think it's wrong. And I believe that's in the instruction details. We've gone a bit over time. We'll continue on next Tuesday, talking more about this config file and demonstrating why it's bad and showing another service as well. Thank you guys for coming and bearing with the screen issues.